everyone, I'm Dilara Halavurt from Bilkent University Electrical and Electronics Engineering Department. Me and my friend Pınar, Ekin, Alparslan had prepared a project for AD8232 Microprocessors course. Our objective for the course was to prepare a project that utilizes FRDM KL25Z board. So, due to our former experience in biomedical signals and instruments course that we took together in the former semesters, we thought we could make use of a heart monitor to meaningfully analyze the data that we obtained from it and make an ECG monitor that calculates the heart rate and RR intervals as well. Actually, our former objective was to meaningfully analyze the data in order to see the heart problems that a patient might have, so that we could diagnose the diseases due to our data like heart rate and RR intervals. But then we thought that we couldn't test it because we didn't have enough patients to test our project on, so we thought we could make a simple ECG monitor. Our monitor makes use of AD8232 Heart Rate Monitor. It outputs two digital, and one analog output. So this analog output gets into the FRDM KL25Z board. The board meaningfully analyzes the data, the sample data, and finds the peak points, counts them, and makes a heart rate estimation. And due to that heart rate estimation, the RR interval will be calculated. Ekin will tell you more about this topic. Another peripheral that we used was the TFT monitor ST7735. We didn't have a built-in library for the TFT monitor and the heart rate monitor, so we had to write all the code by ourselves in C++ language. This is what I can tell you about the project. Ekin will continue to explain you the project in details and show you the demo of the project. Thank you for listening.
Hi, I'm Pınar Alparslan from AD8232, and today I'm going to show you our demo of our final project. For the final project, we did an ECG monitor that counts the heartbeats and calculates the heart rate and our intervals. Our intervals is the distance or time interval between two RR peaks. So for the project, we are using heart rate sensor, which is AD8232. It gets the heart rate from 3 pads, as you can see here. Because there is not a constant heart rate, you can see the LED staying on. If there is a heart rate, the LED actually blinks according to the heart rate. We are taking the heart rate from this sensor, then giving to our microcontroller, which in it, then we take the analog signal. We passed it from a low pass filter. From the low pass filter, we filtered all the noise, all the little noises, and we know that we actually should do 2 more filtering, one for the 50 Hz and the other one for the sinusoidal view of the analog signal. Once we get the signal, we then calculate the heart rate and our intervals, as I mentioned earlier. Then we show the ECG on this LCD. In this LCD, we take 2 points of the analog signal, then we connect the 2 dots to make it an actually ECG graph. Then we show the heart rate and our intervals in another screen, which the screen can be controlled with going to the next page with this touchpad. As you can see, this is not working right now because there's not a constant heart rate coming from the pads. These 3 pads are actually the minimum number of pads that can be used in an ECG. You can either connect the 2 to your right and left wrists and third one to your right ankle, or you can use these 2 to put them on your right and left breasts and one to your stomach, which is simpler because we can, once we did that, we can actually reach the microcontroller and get a better results. Now it's not working and I'm going to put the pads on. It's still not working. So I put the 2 pads and it's still not working because there is not a constant heart rate. Once I put this on my stomach, hopefully it will start to work. Yeah, you can see the constant heart rate from this LED and you can see the ECG since I have the pads on. So I'm going to try the ECG with not breathing. As you can see, there is not a peak and the interval increased. And once I start to breathe out heavily, yes, it freaked out a little bit. So there was a technical difficulty that one of the pads got out. So now I'm going to try it again. So you can see the 2 arrow peaks in one screen and actually the maximum of these peaks increase. So if I just go to the other page with the scroll, my heart rate is 77 and it changed to 761, 67, and according to the heart rate, my RR intervals changed as well. And once I wait for it going, this is the ECG signal again, and I'm going to take out 1 pad. I took it out and it stopped because it's not taking any heart rate. So this was our ECG project. Thanks for listening.